Hello, my name is Nader David. I'm a developer advocate at AWS Mobile, and today we're going to be talking about how to build secure, offline, and real-time enabled mobile apps with AWS AppSync and AWS Amplify. The platform we're going to be building on is React Native, but these tools work for native applications, so for native Android, native iOS, but also for web applications. But really everything we're learning here today can be applied across all of these different platforms. So the agenda for today is we're going to talk a little bit about some of the challenges that you face in modern applications. We'll also talk about how AWS AppSync and how AWS Amplify help address some of these challenges. We'll look at how AWS Amplify and AWS AppSync work. So we'll give an overview of those two technologies. And then we'll demo how to actually implement this in the real world. The demo is going to be starting a brand new mobile application. We're then going to add AWS Amplify and AWS AppSync. So we're going to use Amplify to add different services like authentication, and we're going to be adding an AppSync API using Amplify and adding analytics and things like that. And then we're going to be demoing things like offline scenarios. We're going to be demoing authorization, fine-grained access control. So basically, we're going to be doing this in just about 4 different parts. And the demo is going to be, the last part should last around 20 minutes or so, the demo. So what are some modern app data challenges? Well, first of all, most applications that you use these days work across multiple devices. So when you access your application, you may be accessing it from a desktop at one moment, and then you may go to eat lunch or something, and then you may need to access the same data from your mobile device. And then on top of that, we have multiple users sharing data. For instance, if you have a spreadsheet application or dashboards that are using data from multiple users, this becomes even harder. And we're going to look at how AppSync actually helps address this issue. Also, users want real-time access to their data, and they want instant access to their data as well. So think of applications like messaging applications. When a user is having a conversation with their friend, they don't have to refresh their screen to see the message from the person they're chatting with. That data needs to be available in real time. Also, we're seeing more and more users expect their applications to work offline. Think about if you're using your Facebook application and then you're in New York and then maybe you get on the subway, you lose connectivity. You still want to be able to not only browse your timeline, but maybe you want to be able to interact with messages that are in the timeline. So you might want to be able to upvote messages. You may be want to be able to create messages, and your application, you want it to still continue to work. So the way that might work is when your application goes offline, we now start queuing up different network operations in a queue offline. When the user comes back online, we want to send those in the order which they were created to our API, and we also want to handle the conflict resolution. So we'll look at how that works, implementing AppSync. And we want our applications to be secure, and building secure applications with all of these other challenges in mind, and also understanding how distributed systems work is not an easy challenge. But we're going to look at how to kind of address some of this using these tools. So first of all, we're going to talk about AWS AppSync. AWS AppSync in a quick overview would be something we would describe as a serverless backend for web, mobile, and enterprise applications. The main features we'll touch on here. First of all, enterprise level security. We have first-class baked-in security for 4 different authorization types for your API. We'll go over all those in detail in just a moment. We offer real-time access to millions of devices using AWS AppSync with a implementation called GraphQL subscriptions. When your devices are online, changes happen to the API, data gets pushed or changed in your API, that data can get streamed down in real time. We also, with AppSync, offer offline access to all of your application data using our AppSync clients for native iOS, native Android, web, and React Native. AWS AppSync is a serverless service, so it scales for you effortlessly. And the implementation of AWS AppSync is GraphQL. And we'll go over that right now and just look exactly what GraphQL is. So how does GraphQL work? There's three main pieces to a GraphQL API. There's the schema, there's the resolvers, and then there's the data sources. The schema is where you describe exactly what your application looks like. So here you have all of your types, you have all of the operations that interact with your data source. The data source are an array of different data sources that you might need. So for instance, a typical API might have a DynamoDB table for storing NoSQL data. It might have an Elasticsearch cluster for implementing complex queries. You might also have a couple of Lambda functions in there and maybe even a couple of microservices. The resolvers are the glue that kind of map the schema to these different data sources. So if you have a query that asks for data, the resolver will tell the query where to fetch the actual data, which data sources to go to, and also how to interact with that data source. With GraphQL, you first define your schema. So we have a typical schema here for a to-do application. We have a type defined of to-do. To-do has a few different fields on it. We have an ID, a name, a description, etc. The fields that are required are tagged with an exclamation point. So the ID is required while the name is optional. And in GraphQL, you can have fields that are actually referred to as nullable. So for instance, an optional field is referred to as nullable. That way, when you request the data for this type, the data does not have to be available if it's nullable. So the only required field for this type would be the ID. You then define operations against this type. So here we have both a query and a mutation. A query would be a way to fetch this data from our API, and the mutation would be a way to insert data into the database. Once you define your schema, you then create the data sources that are going to be associated with the type. So for this to-do type, we might have just a basic to-do table. And then finally, we would have our resolvers. And again, the resolver is what is kind of the glue between the schema and the data source. So in the resolver, we'll first choose the data source that we'd like to work with. So in this application, we'll be working with the to-do table we mentioned in the last slide. And then we can define what we would like this operation to do. So for creating a to-do, we want to do a DynamoDB put item. We'll then pass in the key and the attribute values. The attribute values will be the arguments to this create to-do mutation. So for instance, the arguments might be the ID, the name of the to-do, and the description of the to-do. So what are the GraphQL operations that are available? And kind of how do these relate to maybe a typical REST API? There are three main operations that you can do with GraphQL. Queries write data. So you can think of a query as kind of a get item in a traditional REST API. There's mutations, which write data. So mutations would be similar to a put, post, or patch. And then there's subscriptions, which are unique to GraphQL. And this is what you would implement to listen to real-time data. And these subscriptions are typically implemented on some type of event. So on create, on update, or on delete would be very typical subscription events. So whenever one of these events happens, the subscription is fired, and that data from that create, update, or delete is then piped down to all of the different client applications that are subscribed to that data change. So let's look at the life cycle of a basic GraphQL operation. For this example, we have a query. So we have our type of to-do, and then we want to query to get all the different to-dos in this API. So we first create our schema. We then query for this data using that query. So we call get to-dos, and we define the data that we'd like to get from this operation. Here we're saying we want the ID, the name, and the priority. We notice that the type actually has other fields that are available, but we're not asking for that data. We're only asking for the data that we'd like to get. And then we only get that data returned to us. So even though we have other properties in our application like due date and description, we're not getting that data back because we did not ask for it. So what type of AppSync data sources are available, and kind of how does the flow work as far as authorization is concerned to make sure that these requests are authorized? So typically when the application loads, the user will sign in, and for instance, if they're using Amazon Cognito User Pool, the request will go there. It will check to see if the user is authorized. If the user is authorized, then the request is returned back to the client with an access token and ID token. From the client, when we then make requests to the AppSync API, in the authorization header, we'll send this access token and ID token to the AppSync client. The AppSync client will then verify with Cognito that this request is valid. If it is, it will pass on the request to whatever operation that we're working with, so whatever query, mutation, or subscription. And then now in the resolver, in the mapping template, we'll now have the claims about this user in the ID token available to us. So we can get the identity of the user in the mapping template. So we can get the user ID, the username, things like that. The different data sources that are available first class right now with AppSync, we have Amazon Elasticsearch, we have Amazon DynamoDB, Amazon Aurora was recently added, Lambda, and then we also have a basic implementation for adding REST endpoints. So if you have existing REST endpoints or microservices you'd like to add, you can use something called HTTP resolvers to then use the GraphQL AppSync layer as kind of a proxy over all of your existing data sources, regardless if they're actual databases or not. So if you have something like, again, like a microservice, you can actually still implement that as an API using GraphQL. The types of AppSync authorization, there are 4 different types. First of all, there's API key. This is the most basic form of authentication. This offers really no authorization. It's basically any request sent to the API that has this API key in the header can now access this API. There's no identity about the user, nothing specific to the caller at all. We also have 3 different ways to have private or custom access to an AppSync API. The first is the Amazon Cognito User Pools authorization. This is a first-class method of authorization using AWS services, which are Amazon Cognito User Pools. There's also OpenID Connect authorization. This allows you to bring your own authorization provider. So if you're already using something like Auth0 or you have an implementation of your own at your company, you can bring your own authorization provider and use that for access to your AppSync API. And then also we have AWS IAM authorization. So how do you create an AppSync API? Well, there's 3 different ways to do so. First of all, we're going to be looking at how to create an AppSync API using the AWS Amplify CLI, and that's kind of the recommended way to get started with AppSync. You can also go directly in the AppSync console in the AWS dashboard and create APIs. And then finally, you can use a provider, something like CloudFormation, SAM, CDK, or serverless framework. And we see a lot of people going that route if they're already using this in their workflow. So this brings us now to the Amplify Framework. The Amplify Framework now consists of quite a few things. First of all, there's the CLI. The CLI is what you would use to create new AWS services. We also have the AWS Amplify client libraries. These are what you would use to access the cloud services that you created from the CLI from your actual client application. There's also something that was recently launched called the Amplify Console, and this is more for web applications, but it also offers continuous deployment and hosting for your web applications. We also have pre-built UI components for popular front-end libraries. So if you're building in React, React Native, Vue, Angular, Ionic, any of those, we have pre-built UI for things like user authentication, for chatbots, for quite a few different things. There's also the AWS Amplify CLI toolchain. The toolchain allows you to do quite a few things like updating and configuring your services, but also doing things like generating code for you for your AppSync API. So after you've created your AppSync API from the CLI, you can then generate all of the code that you would need on the client using the toolchain. And we kind of mentioned the framework support, and we'll kind of walk through that in just a moment. So the CLI, again, allows you to create and update and delete cloud services. We added recently multiple environment support, so you can have multiple environments that you're working with, so you don't have to kind of be working in production. You can spin off a new environment for a certain feature, develop, and then merge whatever those updates are back into your main environment. The GraphQL Transform library is pretty interesting, and it's also part of the CLI. This allows you to define a really basic schema, and we then take that schema, expand upon it, and add a bunch of different features. So we'll take a look at the GraphQL Transform library here. So here is kind of a basic example of how you might use the GraphQL Transform library. So on the right-hand side, we have a base schema, and all we have here is a type of post. The type of post has two properties, an ID and a title. That's it. And we see that we have this additional decorator of @model defined here. So the @model is kind of what the GraphQL Transform library is going to be using to transform this into a full-fledged API. So just using this @model transform will then generate an entire AppSync API from this base type. So once we run Amplify push, this will generate this entire layout of API in our AppSync dashboard. We'll have not only additional schema created, but we'll also have resolvers, data sources created for us. So in addition, in our schema, we'll have our base type, but we'll also have all the different operations like mutations, subscriptions, and queries that we would need for a typical API. All the different CRUD operations, I guess you might think of these, create, update, and delete. Also, all of the resolvers that go along with these operations. So each of these mutations, each of these queries needs their own resolver to interact with the data source. Those are all also generated for us. And then finally, we also generate the actual data sources. So using the @model decorator, we're going to be given DynamoDB tables that correspond with these types. There are different types of GraphQL transforms that you can use. We looked at @model. This is what you would use to do the DynamoDB table generation, resolvers, and additional schema that we just looked at. We also have an @connection. @connection allows you to define relationships between these types. We have auth. Auth allows you to set authorization rules. We also have searchable, which allows you to set up a model with an additional Amazon Elasticsearch service. So this will not only create this DynamoDB table, but it'll also set up streaming for all of the data from the DynamoDB table to the Amazon Elasticsearch service. And then it'll also generate schema for creating search queries from your API. So that's the CLI. The client is going to be, again, what you use to interact with these different cloud services once you create them. So you'll use the CLI to create the services, then you'll use the client to connect to the services. And the different front-end libraries that we have support for right now, for native, we have native iOS and native Android support. And for web and JS frameworks in general, we have support for React, React Native, Vue, Angular, and Ionic. And then finally, we have the Amplify toolchain. This is kind of really part of the CLI, but it allows you to configure existing resources and do GraphQL code generation. We'll be looking at the GraphQL code generation in just a moment. So what does an actual typical workflow look like with all of these different tools we just kind of looked at? Well, typically you will either create or open your existing application that you're kind of working with. This would be something like an iOS application or React Native application. You would then initialize a new Amplify project from the root of this application. You can either initialize an existing Amplify project. So if you have an Amplify folder you'd like to import that has specific services already set up, you can do that, or you can initialize a brand new Amplify project. After you've initialized the Amplify project, you can then start adding new features. You would then run something like Amplify init to initialize the new project, and then Amplify add, and then the name of the service to start adding new services. You could then initialize a new environment to add these different additional features if you would like. So for instance, say we wanted to add a new API, but we didn't want it to affect our existing environment. We might initialize a new environment, create that new feature. Once we've tested it out, we could then merge it back to the main environment. Once we've tested out this new feature, we can then push the changes to our main application by running Amplify push. So let's go ahead and take a look at the demo to kind of implement all of this stuff. So for the demo, we're going to be working with a React Native application. And here I am in a newly created React Native application. And we're going to be kind of going through this demo in 3 steps. First of all, we're going to start with a blank React Native app. We're going to add and initialize a new Amplify project in this blank React Native app. And then in step 2, we're going to add a new service to the Amplify application. And then in step 3, we're going to implement the actual features in a client application, which is the same React Native app. We're going to be working with analytics. We're going to be adding user authentication, and we're also going to be adding the AppSync API. And then down the road after that, we're going to try to implement some user authorization and fine-grained access control on our data. So now in our React Native app, we can run Amplify init. This will initialize the new Amplify project. It's going to walk us through a few steps now. So for the name of the project, I'll call this RN Amplify app. For the name of the environment, I'll just call this local. Now it's going to ask us for the default text editor that we'd like to use. So you can choose the default editor you would be working with. For me, that's Visual Studio Code. Next, it's going to auto-detect now that we're in a React Native project, and it's going to start automatically selecting the right choices for us. So the type of application that we're building is JavaScript. We are in a React Native app. It's going to ask us for our source directory, distribution directory, build command, and start command. All of those are going to be already kind of chosen for us based on the fact that we're in a React Native app. Next, for the AWS profile, we can either use an existing AWS profile or create a new one. I'll choose yes to use an existing profile, and I will use this EU Central user. So this is going to go ahead and kick off the new Amplify project for us. After the Amplify project has been kicked off and created for us, we'll now have a couple of new files and folders in our project. First of all, we'll have this AWS exports.js file. This is going to hold the configuration for each of the individual services that we're going to be working with from AWS. And then we'll have this Amplify folder. And this Amplify folder is going to hold all of the files associated with this Amplify project. So if we look at AWS exports.js, for instance, we'll notice that right now we only have an object that's been defined that has a key and a value for the project region. And since we chose EU Central 1, that is the region. But as we start adding services like API, we start adding authentication, we'll start seeing those different services defined here in this AWS exports file. And this is completely handled for us by the CLI. So now that we have the Amplify project initialized, we'll go ahead and add our first service. So the service that we'll add is analytics. Well, first we'll add auth maybe. So this is going to give us the option to either choose a default configuration that is set up with kind of best practices around a basic authentication flow. So for signing up, we're going to be given a username, email, and password that's going to be set up through email multi-factor authentication. So you'll have an email MFA code emailed to you after the user signs up. And then when they sign in, all they are required to have is their username and password. Or you can kind of go through a custom configuration that will walk you through all the different steps that you would need to kind of define exactly how you would like that set up. For this demo, I'm going to go ahead and choose the default configuration. After we've added our authentication service, we can now run Amplify status. This will show the current status of our application. So now that we've created our Amplify application and we've added a single service, we now see that we have our current environment listed. For the environment for this step 2, we're in dev. And for the categories that we now see we have a new category of auth, and the operation is set to create. That's because we haven't actually pushed this new application up to our account yet by running Amplify push. That means the next time we run Amplify push, the operation will be set to create. So now that we've added authentication, let's now run Amplify add analytics. Add analytics. This will give us the option to define a pinpoint resource name. So I'll call this Amplify RN app. And then we're asked if we'd like to allow unauthenticated access, and we'll just go ahead and choose the default there. So now we have both authentication and analytics added to our configuration. The last thing we want to do is we want to add the AppSync API. So I'm going to run Amplify Add API. When we run Amplify Add API, we have the option of two different API types. We either have GraphQL, which is going to be AWS AppSync, or we can use a REST API, which is a combination of API gateway with a Lambda function running a serverless Express application. So I'll choose GraphQL, and for the API name, my to-do app sounds good. And for the authentication type, we're going to go ahead and choose Amazon Cognito user pool. And since we already have an Amazon Cognito user pool in our application, it's going to automatically detect that, and it's going to say use a Cognito user pool as part of this project. And that's basically saying it's using the configuration that we already have added to this project by default. Next, it's asking us if we have an annotated GraphQL schema. So if we have a schema that we'd like to use already, we can actually just reference that here, but we don't, so I'm going to choose no. And if it's going to ask us if we'd like to have a guided schema creation, I'll go ahead and choose yes. And it's going to give us three base types to kind of start off with. So this is going to be a template almost that we're going to be given, and we can then use that to kind of edit the template that we're working with. So we can either go with a single object with fields. We can go with a one-to-many relationship. So this would be kind of two types with an at connection relationship, or we can have fine-grained access control out of the box. I'm going to just choose this single object with fields to kind of start off with. And we'll choose yes to go ahead and look at this basic schema. So we're given this basic schema of a to-do, and we see that we do have this @model decorator. We have three fields to start off with. We have an ID, a name, and a description. And for our to-do app, we might also want to have like a completed Boolean, or maybe or maybe like a status might make sense. So let's say status, we'll set this to string. That way we can say whether or not the to-do is pending, maybe it's completed, or maybe we're currently working on it. But either way, we can set that to a string to kind of define that status. So after we do that, we'll go ahead and save the schema, and we'll jump back to our command line. And after we've saved the schema, we can press continue, press enter to continue. Now our Amplify CLI has created this AppSync resource for us. So if we run Amplify status, we'll now see that we have this new category of API added here. We also have analytics added, and the operation is set to create for all of our resources. So to go ahead and create these resources, we'll run Amplify push. This will go ahead and push all of these new resources to our account and create these services. Now, since we're adding a new GraphQL API, we're going to be given the option to do some GraphQL code generation using the toolchain. So I mentioned earlier, once you create your GraphQL API, we can generate all of the client-side code for you. So it's asking us if we'd like to generate that code for us locally. I'm going to go ahead and choose yes. This will then prompt us for the type of language that we're working with, JavaScript, TypeScript, or Flow, the file pattern where we'd like these to be created, and whether or not we'd like to generate all the possible operations. I'll go ahead and choose yes. So this is going to go ahead and generate all of the different GraphQL queries, mutations, and subscriptions for us locally. Then we can just import those and use them in our app. So after that's complete, we'll then go ahead and jump to this step 3. And now if we look at our AWS exports file, we'll see that we now have additional configuration added. In addition to the region, we have our Cognito identity pool, we have our user pool, we have our analytics, and we also have our GraphQL endpoint. So this is kind of referencing all of those different services we just added. We now see that our AWS exports is automatically updated for us. So now we want to go ahead and start implementing these features one by one. So I'm going to jump to the React Native app. And here we see that we have a basic React Native app running, nothing special going on. This is just the boilerplate that React Native gives you when you create a new app. We'll go ahead and first use the authentication service to go ahead and add authentication, and then we'll add the GraphQL API to our app. So I'll go ahead and jump to the code. The first thing we'll need to do is we'll need to open up index.js, and we'll need to configure our React Native app to know about the Amplify project. And we do that using Amplify configure. So we first import Amplify from AWS Amplify. Then we import the AWS exports file, and I name that config. So this is that exports file that we looked at just a moment ago. So we import Amplify. We import this config, and then we just call amplify.configure at the root level, which again is at this index.js file. This will go ahead and configure our entire application to recognize all of those Amplify credentials that are available to us in AWS exports. Once this is configured, we can now start working with the services. So the next thing we'll do is we'll go in app.js, and I'm going to start by kind of deleting some of this boilerplate that we're not going to really need. So now we have our React Native app that's just going to say welcome to React Native, and to get started, edit app.js. And what we want to do is we want to first add authentication to this component or to this application. So to do so, we're going to import the with authenticator higher order component from AWS Amplify React Native. The with authenticator higher order component is a component that's going to wrap our entire application with an entire authentication flow. There are a couple of different ways to kind of implement authentication using AWS Amplify. We can actually import the auth component directly from AWS Amplify. This will allow us to have like over 30 different first-class methods on the auth class. So we can call auth.signin, auth.signup, so on and so forth. But then we would have to kind of write our UI ourselves. With the with authenticator how order component, though, we're going to be given an entire UI that's kind of scaffolded for us. And instead of exporting the class as the default export, we're going to update that to be the with authenticator how order component. So we'll export the with authenticator as the default export, and then we'll pass in the app as the first argument. And then the second argument, we can pass in some configuration. I'm passing in include greetings set to true. This is going to basically just give us a sign out button. So after we've saved that, this is all we need to go ahead and add authentication. So I'm going to jump back to the React Native app and refresh. And we now see that we have an authentication flow in front of our application. So what I'm going to do is I'll go ahead and click on sign up, create a new user. Once we sign up, this is going to send us in our email a multi-factor authentication code. So we check our email for MFA. We grab our verification code. And then we should be able to go ahead and confirm this new account. So now that we're confirmed, we'll go ahead and sign in. There we go. So we're signed in. We see that we have our welcome to React Native, to get started, edit app.js. We also have a little greeting here at the top that says hello with our username, and then we have a sign out button. And we'll notice that if I click Command R to refresh, that when the application refreshes, we see a little loading indicator, but we then get automatically logged back in. That's because the user's authentication state is persisted to the application. So as long as the tokens are still valid, you're going to stay signed in. You're not going to be signed out unless you explicitly sign out. So now that we've implemented our authentication flow, we want to now add our API. So we'll jump back to the app and we'll do that. And to do that, we're going to start in index.js because we need to import quite a few more things here. So we'll go ahead and import everything we need for the AppSync client. And we'll import React from React because we need to create a new React component. We're going to import the AppSync client. This will allow us to use our AppSync configuration to create a new client variable. We'll import the rehydrated component from AppSync React. This essentially lets us wrap our main app component, and it will prevent the application from loading until we've already rehydrated the store from our local cache. We also import Apollo Provider from React Apollo. This is what's going to allow us to inject the AppSync client into the React context. And then we import the auth class from AWS Amplify. This is something we're going to be using to get the current information about the logged in user and pass it along to our AppSync requests. Next, after we import all of those components, we'll create a new AppSync client and a variable we'll call client by calling new AWS AppSync client. Here we pass in the URL and the region for the client application, and then we pass in an auth object that kind of defines how our authentication is going to be set up. So we pass in the type of AppSync authentication type. If you remember when we created this AppSync API, that was set to Cognito user pools. So if we open up AWS exports, we'll see that we have that authentication type defined here, and that type is set to Cognito user pools. We also have a JWT that's set to auth.currentsession, and then that actually gets the ID token, and from that gets the JWT. Now that we've created the client variable, we create a new component called AppWithProvider. AppWithProvider returns an Apollo provider passing in the client that we created earlier as the client. We then wrap the app component in this rehydrated component, and then finally we have the main app component there. And then instead of rendering the app, we render the AppWithProvider. So I'll go ahead and save that. And this kind of is what we need to initialize the main AppSync client and have all of the data available to us and all of the different components in our app. So after we've defined all of that, we'll jump back to app.js, and we'll go ahead and implement, first of all, we'll implement queries and mutations. So to implement the queries and mutations, we'll first need to go ahead and import all the different things that we're going to need. Now this looks like quite a bit, but in reality, these 3 lines are the main things that are going to be used to actually interact with the API. These are just our GraphQL query definitions and mutation definitions, as well as a few UI components from React Native Elements. So first we import GraphQL and Compose from the React Apollo library. Compose allows us to compose multiple GraphQL operations into a single higher order component, and then the GraphQL helper allows us to define those different GraphQL operations. We also import build subscription from AWS AppSync. This is an offline helper, or really just a helper, I guess you'd say, that allows us to abstract away a lot of the code that goes into writing a GraphQL subscription. Typically, writing a GraphQL subscription consisted of writing at least 20, maybe 30 lines of code to kind of define how the data is going to be processed. This allows us to kind of abstract that away into just a couple of lines of code. And then we also have the GraphQL mutation helper. This comes from AWS AppSync React. This, similar to the build subscription helper, allows us to abstract away quite a bit of code into just a single line of code. So typically when you have a GraphQL mutation in a client application, you need to implement things like an optimistic response and an update function to kind of update the local cache or the local store. That typically takes anywhere between 20 to 30, maybe even more lines of code. This kind of abstracts it away into a single line of code. These three components from React Native Elements just kind of allow us to build a form with not much code. And then we have our GraphQL operations from our queries, our mutations, and our subscriptions imported right here. These operations were created for us by the CLI earlier. If you remember when we were creating our API, it asked us if we'd like to create these different definitions locally, and we chose yes. So for instance, if we look at queries.js, we see that we have our get to do and our list to do queries kind of defined for us. All we're really doing in this file is kind of importing those operations here. So now that we have all of our imports, we can now create some initial state. The initial state that we're going to be having is name and description. This is for us to create a form that allows us to kind of have an input for the GraphQL operation that we're going to be kind of using in just a moment. So when we create a new to-do, we need to pass in the name and the description. We're going to have a form input that kind of allows the user to type, and we're going to save that into the state. Next, we need the methods that are going to actually update the state. So the methods that we're going to be having to update the state are going to be actually just a single method that's going to be onChange. This is going to take in a key and a value. The key would be something like the name of the to-do, and the value would be something like the value of that name. So when we call this.setState, we'll be setting the name to the value of the name that's currently being typed, and the same with description. And then we have a createToDo method. This is going to be what calls the API and creates the new to-do. And this is going to call this.props.createToDo. This.props.createToDo is going to be passed down in just a moment in our higher order component. The createToDo method is going to pass in this state object with the name of the to-do and the description of the to-do. And then after we call that, we call this.setState, resetting the form to clear out the input fields for name and description. Finally, we need to actually render this UI that we're going to be that we're kind of referencing here. So the UI that we're going to be having for this application is going to be a really basic form with two inputs, one for the to-do name, one for the to-do description. It'll have a button. This button will create we'll call the createToDo method when pressed, and we see that we have the title as add to do. And then finally, in our UI, we want to kind of show all of the to-dos in our application. So we call this.props.todos.map, and for every to-do in our application, we're going to be showing the to-do name and the to-do description. So if we have a to-do for get groceries and the name of maybe the grocery store, we'll show that to-do name and the description below it. So now that we have kind of most of that built out, the only thing we need to do now is define the actual GraphQL operations. The two operations we're going to be kind of starting off with are going to be the createToDo operation for creating a new to-do, and the listToDos query to query all of the to-dos in our app. So we'll look at the createToDo first. This is a really pretty simple operation, just a single line of code. We're using the GraphQL mutation helper, and GraphQL mutation takes in three main arguments. The first argument is the name of the operation, which is the createToDo operation, the createToDo mutation. Then we need to pass in the query that needs to be updated optimistically. So since we're querying for to-dos, when we create a new to-do, we want to be able to optimistically update our UI with the new value that's going to be kind of passed into our API before. We don't want to basically wait for the to-do to be created in our API and then come back. We want to go ahead and optimistically say, hey, when we create a new to-do, we want to assume that it's going to work, and we want to update our UI. That's done by passing in this query here So the the GraphQL mutation helper kind of abstracts away all of that for us. And then the third argument is the type. And for us, the type is to do. Second, we have a GraphQL operation for a query of list to-dos. We set the fetch policy as cache and network. That is basically saying when the application loads, we want to fetch the to-dos from the cache. And then once the network actually fetches the new data, we want to then update the cache with the new data from the network. And then for the props that we're passing down, these are going to be the props that are then passed down to the component. So we mapped over the this.props.todos earlier. That value is coming from this to-dos that we're kind of passing in here. And then we just pass in the entire data object as well because we'll need that in just a moment. Now, instead of rendering the app, we'll then instead render the app with data. And by replacing that, we're basically saying we want the app, but we also want the app to be kind of merged with all of these GraphQL operations as well. So now if we save that, and we jump back to our app and refresh, we now see that we have a form there. And I think I need to go ahead and update one more thing in our application. I'm going to go ahead and delete this justify content and align items center from our container and refresh one last time just to kind of make sure when the to-dos are rendered that we don't see an ugly design. Also, it kind of bumped the form up to the top. So we'll test this out by creating a to-do name and a to-do description. So I'll call this get groceries. I'll say steaks and vegetables. And then we might just have another to-do. I'll just call this to-do 2, and then some description. And we notice that when we click Add To-Do, the to-do is automatically updated in our UI without us having to wait for any network requests. That's because we use that create to-do, that GraphQL mutation helper that automatically updates our local cache with an optimistic response. So now that we have that working, let's kind of take a look at the API implementation in our AppSync dashboard. So I'm going to go ahead and jump to the AppSync dashboard for this API and take a quick look. So in our AppSync dashboard, we have on the left-hand side kind of a menu of all the different things we can do within our app. So we have a way to look at our schema. We have our data sources. We have a few other options. So in the data sources, this is going to be kind of what we're going to go ahead and take a look at. So here we have our to-do table, and we have the type of table is DynamoDB, and then we have a link to the actual resource. So I'm going to go ahead and click on that link, and this is going to take us to our DynamoDB table with our items. So here we see that our items are listed, and we have two to-dos. We have our boss steaks, and we have our to-do 2. So we see we have both of those available to us. I'm going to leave this open because in a moment this is going to be important once we start implementing fine-grained access control and authorization. So in addition to that, I'm going to go ahead and jump back to our API. And we want to be able to next test out real-time because we talked about real-time as one of the things that we'd like to kind of have in our app. To do so, we're going to need to implement subscriptions for when a new to-do is created. We want to be able to kind of listen to that on create operation and then subscribe to that. So to do so, we're going to need to kind of test that out. And to test that out, we're going to want to be able to kind of create new to-dos from our dashboard. So to do that, I'm going to try to go ahead and use the query editor from the AppSync dashboard. So first I'll go ahead and log in using the username I created earlier. And I'll go ahead and query for all the to-dos. And I might go ahead and create a new to-do to make sure this is all working properly. And if I jump back to my app, we should now see 3 to-dos. Okay, great. So that's working properly. Now let's test out subscriptions. So to do that, we'll jump back to our app, and we'll go to our component did mount lifecycle method, which would be implemented right here. And here we're going to be calling this.props.data. So earlier we looked at where we implemented the props for our query. We also passed down the data object. That is now being used here as this.props.data. And we're calling subscribe to more. And here we're just passing in the build subscription helper. And we're passing in 2 arguments. The first is the subscription we'd like to be listening to. That is on create to do. So when a new to do is created, that's the subscription we're building this around. And then we're passing in the query that we'd like to have updated. So when a new to do is created, we want to then update this list to dos query with that new to do. And this is all done in, again, just a single line of code. So if I go ahead and save that, we're going to test this out by opening the console. And I'm going to also have the app running right here on the left-hand side. So if I refresh, we're going to now create a new to-do, and hopefully when this happens, we'll see the new data kind of update on our mobile app. So I'll call this to-do from subscription. And this will be called maybe real-time data. Create. And now we see that we have this real-time data coming through here. And I'll make one more just to kind of double show this again. Create. We see that the subscription is indeed working. We have the real-time data working. So we've implemented the queries. We've implemented the mutations and subscriptions. Now we want to start adding some fine-grained access control to this app. So the first thing we'd like to do that is we need to associate each piece of data with the currently logged in user. So we want to say when a mutation is created, we want to associate each item with some type of user data. There's a few ways to do that, but I think the best way would be to do this in the mapping template. And we're going to do that so no matter what happens, we don't actually have to say that we have to pass in any information from the client. We automatically want to detect that in the resolver and then just put that information in the database. So to do so, we'll open the schema and we'll go to the resolvers and we'll look for the create to do resolver. So whenever we create a to do, we want to now start adding information about the user. So here is the create to do resolver. And again, the resolver is consisting of 3 main things: a data source, which is the to-do table, the request mapping template, and the response mapping template. In the request mapping template, I'm going to do a new operation that's going to add a new property to our input. Right now, our input has the to-do name and the to-do description. We also want to add information about the user. So I'm actually just going to copy this line here, and I'll update it. So we want to add a new item to the input. So we're calling args.input.put. Here we're going to say user ID. And we can now start detecting the user ID from the context. So I can say context.identity. Context.identity is an object that contains all the information about the caller. So we'll have user ID, we'll have sub, we'll have a bunch of different properties. But I think the sub is what we're going to be working with. This is short for subject, but it's essentially a unique identifier for the user that's making this API call. So now whenever a new item gets created, we'll add a new property called user ID, and this will be set to the value of context.identity.sub. So if I save this resolver, and I go ahead and create a new to-do, so I'll say to-do with user info. I'll add this to-do here, and if I go to my DynamoDB table, we should now see a single to do with the user's user ID, and that's this to do with user info. So we're now storing user info in each operation, in each mutation. Now we want to be able to query for that data based on who the user is. So let's go ahead and create a new query in our schema to do that. And the easiest way would probably be to take an existing query and just kind of update it from there. So we know that list to-dos already returns this entire list of to-dos. Let's create a new query that's similar to that, but only queries for the currently logged in user's data. So I might call this to-dos for user. And we can even have this return the same connection, model to-do connection, as this list to-dos, because we want the return data to kind of look the same. The only difference is going to be in the implementation of the actual resolver. So if I go ahead and save this schema, I can now go into my resolvers and find this new query that we just created, to-dos for user. And here we can implement the actual resolver for this query. So we have this query set up here. We have the data source set to TodoTable. I'm going to kind of write this again from scratch to kind of show you what's going on. So here in the dropdown, we have a bunch of different mapping templates that are predefined for you. So we have things around batch operations, around authorization. The query that I'm going to be working with to start off is a query with the filter on an index. And I'll delete any of this comments that we don't need. And I'll also go ahead and delete some of the code that we're not going to be using just to make this a lot less verbose. But what we'd like to do is we want to query, and we want to query on the index of user ID. So we want to be able to say we only want to fetch data from this user ID index. So to do that, we're going to set the index as user ID index. We'll set the expression to be user ID, and the expression name to be this colon user ID that we're defining here. And for the actual user ID, we can just pass in the context.identity.sub that we used earlier. So now, instead of actually having to pass in an argument, it's automatically going to detect the user's identity and use that as the value to query on this index. And then we do also want to return a paginated list of results. So we're going to have this items array and a next token if we'd like to do pagination. So I'll go ahead and save this resolver. And now if I jump back to queries, we'll try to use this new query. So now if I go ahead and hit this query for to-dos for user, so now when we query using this to-dos for user query, the only data we're getting back is the data associated with that user. So if I refresh my app, we still get all of the data that we're querying for because we're using that old query, but we'll go ahead and update that to use this new to-dos for user query. So to do that, I will go into my queries and I'll go ahead and add a new query that's very similar to this list to-dos, and I'll call this to-dos for user. And save that. Go into app.js and import this new query. And now anywhere that we use a list to-dos, I'm just going to update that with the new query of to-dos for user. So now our app is updated with this new query. So hopefully when we refresh, we should only be getting the data that was created by this user. There we go. We only have a single item. So so now we have this user authorization with fine-grained access control kind of on this single query. So we're only getting the data that we'd like to for this single user. If you're looking to learn more about AppSync and Amplify, I would totally check out the documentation on both of those. We have a lot of example projects, example videos, and things like that to kind of get you going. If you have any questions, you can feel free to reach out to me. My email address is david@amazon.com. Thank you.